we have finished our Module 1, which is all about the essence of designing. Okay, so i-recall lang po ulit natin. Okay, so we have there the 4 steps involved. Okay, let us have the first one. Paki-recite nga po, ano yung una? Anybody? Hello? Yes. Olma?
Know the property of material po.
Okay, know the property of the material as to code and as to strength. Number 2. Okay, Sir Dan?
Ano po, apply a suitable factor of
Okay,
safety.
apply a suitable factor of safety. Okay, so doon po sa knowing property, you can classify the material as to ductile or brittle material. And then on number 2 naman po, okay, you have the factor of safety which depends on yung pong tatlo na consideration. Una po is the kind of load, pangalawa is the type of material, and then the last one would be the basis of design. Okay, we go with number 3, Phil. Phil?
Ang number 3 po ay determine the design stress po.
Okay, so determine the design stress. Okay, so for the design stress, we have in form of sigma and tau, and that is dependent on the loading na meron po tayo dun sa material. Okay, so if the type of loading is axial and bending, and come up with yung sigma. Okay, and gagamitin naman po natin yung tau if we have shear and torsion. And then the last one, Justin.
For a good design, equate the design stress to the induced stress of the material.
Okay, tama po yun. Okay, so that's the last one. Okay, you equate the design stress to the induced stress of the material. Okay, doing that, you would arrive at the most suitable dimension, okay, of the machine member that you are designing. Okay, so yan po yung mga steps na ipa-follow natin whenever, okay, we solve for a design problem. Okay, so yan din po yung i-apply natin to this first topic that we have on our module 2. Okay, so let us have module 2. This is the first one is machine member under pure tensile load. Okay, so how do we design these members na ang naka-load lang po sa kanya is simply a tensile load? Say for example, this is our machine member, okay, and then this is yung load po na naka-apply sa kanya. So this is our tensile force. Okay, so what is then the effect of this tensile force on your material? Ano po bang epekto niyan? If we subject the material to a tensile load, what will happen? Hello? Yes po. Eric?
Mag-elongate po yung material.
Okay, so there would be corresponding deformation. Specifically, it would have its elongation. Okay, so pertaining to the original length, okay, then mag-i-increase po yung kanyang final length. And at the same time, you notice this one, okay? So nagkakaroon din po siya, okay, at the same time, no narrowing of the cross-sectional area. Okay, so lumiliit naman yung cross-sectional area niya. Say for example, ang palta natin yung sample natin and we make use of a circular cross-section. Okay, so halimbawa circular cross-section, and then we apply this yung pong ating tensile force FT. Okay, yan. Okay, so this is the cross-section of the member, and pag sinabi natin na design, you are to determine what would be the dimension, okay, what would be the particular diameter that we will be using, what would be the safe diameter. Okay, so yun yung focus natin dito. Okay, a member and then subjected to a tensile load, what would be the dimension. Okay, so in order to do that, okay, we will be considering 2 failures. Okay, so we will have first design based or against the strength failure. Okay, so designing against the design failure, we are to come up with its induced stress. Okay, so induced stress yung i-consider natin. We all know if the material is subjected to a tensile load, that induced stress is called a tensile stress. Okay, so as its equation, we make use of sigma for the tensile stress and then subscript T. And this is simply equal to the force, the tensile force over the area. So, ang titignan lang po natin ay yung area po na iyon. Okay? So, if it is circular, okay? So, if it's circular, yung area po natin would be pi d squared over 4. Okay? So, ito po yung diameter. Hahanapin po natin yung diameter po na iyon. Okay? So, ito po yung papalitan natin. Okay? So, on this particular sample, the tensile stress, force divided by area. Okay? So, we have here, yung area na yon papalitan natin ito, pi d squared over 4. That is why you come up with the tensile stress equal to 4F over pi d squared. Okay? So, ito po yung ating induced stress. Ito po yung ating tensile stress. Okay? So, iyan po. Now, sabi po natin doon sa essence ng design, sa number 4, for a good design, you equate the design stress to the induced stress of the material. Okay? So, you equate the design stress to the induced stress of the material. So, let us again recall yung design stress. Okay? So, ano ba yung design stress natin? Okay? So, the design stress can be based on ultimate and can be based on yield, dependent upon the requirement po ng problem natin. Okay? So, pwede po siyang based on ultimate strength, based on yield strength. So, sabi ko nga po, basahin nyo ng maigi yung atin na problem. Okay? Ano ba yung sinasabi doon sa problem? Is it designing based on ultimate ba or designing based on the yield po ba? Okay? Pag hindi po sinabi, that is the time that you would go back to the type of material. And with the type of the material, yan na ngayon yung magiging basis nung iyong design. Okay? That if it is a ductile material, you base design on the yield. And if it's a brittle material, you base design on the ultimate strength. Okay? So, wag po tayo malilito doon. Okay? Now, for the design stress, you have there two forms. One in terms of sigma and then the other one in terms of tau. Okay? So, dito po in particular, we will be using here po in terms of sigma. Okay? Bakit po in terms of sigma? Simply because your induced stress, okay, it should be of the same type doon sa design stress. And we all know kapag po siya ay tensile stress, it will make use of sigma. That is why our design stress po ay di sigma din po yung gagamitin po natin. Okay? So sabi ko nga po sa inyo, wag to ay maglalahok-lahok. Okay? Kailangan kung sigma, sigma yan. Kung tau, tau po. Okay? So this design stress, this can either be sigma u over Fs o kaya naman po, we can use sigma y over factor of safety. Again, ari po ay gagamitin if design is based on ultimate. At ito po namang pangalawa ay gagamitin if design is based on yield. Okay? Pero kung wala pong sinabi, we stick with yun pong type ng material. Okay? Ductile for yield, brittle for ultimate. So, yun po yung gagamitin natin dito. Okay? Now, so, ibalik po natin doon sa equation, okay? You need to equate the design stress, okay, to the induced stress of the material, okay? So, say for example, okay, so for a good design, sigma D is equal to your tensile stress, okay? So, say for example, yung tensile stress natin, okay, circular, katulad nung nakita po natin kanina, then the tensile stress will be equal to 4F over pi d squared. So, ito na po yun, 4F over pi d squared, okay? And then, ano po yung design stress? If it is based on ultimate, then this would be sigma u over Fs, okay? Kung siya naman po ay based on yield, then that would be sigma y over Fs equal to 4F over pi d squared. Okay, so maalin lang po dito sa dalawa, yun po yung ating gagamitin. Okay, now you look at our equation, okay? Sigma u over Fs equal to 4F over pi d squared. Ito naman, sigma y lang po yung naiba. And then let us evaluate each component po. Okay, yung sigma u, At saka po yung sigma y, saan po ba natin makukuha yung values ng dalawang ito? Hello? Sigma u and sigma y. Okay, tama po. Doon po sa table of properties natin. Okay? So, titingnan lang po natin yung mga design tables and then look for the particular material po na gagamitin. Okay? So, kunin po natin yung value ng sigma u and sigma y po nila. Okay? And then you have here the factor of safety. Okay? In particular, this factor of safety, this will be taken from table 1.1. Okay? So, doon lang po natin yung kukunin. Dito naman po on the other side, on the induced stress, the tensile force, okay? So, this tensile force is usually given. So, it is the diameter that is unknown. So, using these equations, you would be able to find the value of the diameter. Okay? So, makakasolve po tayo dyan ng diameter. So, the computed value, ang lagi lang po nating tatandaan, is to be converted to the standard size for it to be given credit. Okay? So, yung na-compute po natin, i-convert po natin sa standard size. So, yung dimension po natin nakuha dito, yung dimension po na nakuha natin is basically galing po doon sa induced stress ng material. Okay? So, yun po yung isang paraan to obtain the diameter or the dimension. Okay? The other one naman po, katulad ng tanong ko sa inyo kanina, okay? If you have a material and then you load it with a tensile force, ano yung posibleng mangyari sa kanya? So, you say, nagkakaroon po siya ng elongation. Okay? Nagkakaroon po ng pagbabago din to the cross-sectional area. So, ibig sabihin, deformations occur. Okay? So, base po doon sa deformation, okay, doon naman po tayo ngayon kukuha ng dimension. Okay? Doon po tayo magbabase ng design po natin on the deformation of the member. Okay? Now, so, ang deformation po in particular of a material na in-applyan po natin ng tensile load, ang tawag po natin doon is an axial deformation. Specifically, we call it po an elongation. Okay? So, yan po kapag ang material ay ina-applyan ng tensile force. Okay? So, we know po kasi that these materials are deformable bodies. So whenever we say deformable body, when you apply a force to it po, okay, deformations would occur. Okay? Not unlike po doon po sa statics. Sa statics po kasi, ang ating focus doon, it's a rigid body. So therefore, hindi po siya magkakaroon ng deformation. Okay? Hindi po, wala pong deformation tayong kinocompute doon. We are simply after the forces that are acting on the body. Okay, pero sa deformable po, yun po yung tiningnan natin. What would be the relation between yung pong force na ina-apply natin with the deformations it created on the material. Okay, so sa design po, ganoon din. Kukunin nila natin yung deformation niya at yun yung magiging basihan natin pagpili ng tamang dimension. Okay? So, paano naman po gawin yon? Okay? So, ito po yung pangalawa. Yung una po is base sa strength failure. Ang pangalawa po ay base sa deformation failure. Okay? So, sa deformation failure po, i-recall po natin yung equation po natin for an actual deformation. Okay? So, this is our deformation symbol equal to FL over AE. So, we will be using here the tensile load. This L po is the original length, area ng cross-section, and then E is called the modulus of elasticity. Okay? Again, different materials po, you would have different values of E. Okay? So, magkakaiba po yung value nila. Okay? Now, say for example, katulad po dun sa itaas, we make use of a circular cross-section as an example. So, therefore po, again, yung A po na yun po yung applyan natin ng equation, okay, doon para sa circular. So, we come up po with actual deformation equal to the tensile load, original length. Ang area po magiging pi d squared over 4. And then we have here the value of E. Okay? So again, ang tawag po natin sa E is the modulus of elasticity. So saan po natin makukuha yung value ng modulus of elasticity? So given a particular material, dun din po sa kinukunan natin ng sigma U and sigma Y values, dun din po natin kukunin yung value ng E. Halimbawa po, so kunin po natin is for C1020 as road. Okay? Say C1020 as road. So puntahan po natin yung design tables po natin. Okay? So 1020 as road may be seen at table 87. So everybody, you go to table 87 po. Yan. Okay? So ito po yung table 87. Then you look for C1020 as road. Okay? Yan. Ito po yung C1020 as road. So ito po yung sinasabi ko na dapat pag naghanap ka ng value ng E, titingnan mo po muna within po yung kanyang linya. Okay? Nung particular material po natin na binabanggit. Okay? So ari po yung ating C1020 as road. Okay? But then, looking at those columns po, okay? Yung mga columns po na yon, ano po ba yung nandito na values? Ultimate strength, sigma Y, sigma U, okay? Percent elongation, percent reduction in area, and the Brinell hardness number, okay? So, ang kailangan po natin is the value of E, which is the modulus of elasticity. Okay? But then, pag tinignan po natin dito sa table 87, wala naman po dun sa hanay ng 1020 as road yung value ng E. Okay? So, if that is the case po, katulad po nito, na wala po doon sa hanay, ano po yung pwede nating gawin? Ang sunod mo po pwedeng tingnan would be the heading ng table. Okay? Ito po yung heading ng table. And you would observe po, dito po may binanggit na tungkol sa modulus of elasticity. Okay? Modulus of elasticity in tension or compression, you have this value, E equal to 30 times 10 to the 6 psi. But then for wrought iron, you will be using 28 times 10 to the 6 psi. So, ibig sabihin po na ito ay nandito sa itaas po noong do sa heading po ng table natin. Ibig sabihin, all materials listed here on table 87 would have this value of E. Okay? So, kumbaga, lahat po sila, yun yung value ng E. Okay? Mapera lang po sa wrought iron. Okay? Yun po yung kanyang value na 28 times 10 to the 6. Okay? But then all of those, ito po yung kanyang gagamitin. Okay? So, ganun po natin hahanapin yung modulus of elasticity E. Okay? Una po ay dun mismo sa linya ng material. Okay? Pag wala po doon, ano po sunod na titingnan, yun po heading ng table. Baka po sakali na doon po nakalagay yung value ng modulus of elasticity. Okay? Nasundan po ba? Hello?
Yes po, ma'am.
Okay. So, what naman po, may nagtanong kanina, what if naman po, okay, wala pa din doon, okay, wala po doon sa linya niya, okay, tapos wala din doon po sa heading ng table, okay. So, saan ko po makukuha ang value nung E po na ito, yung po ating modulus of elasticity, okay. So, kung wala po doon sa dalawa, saan po pwedeng makita yung value nung modulus of elasticity, okay. So, kung wala po mismo doon sa table, we can assume to use po this value. Okay? E of steel is 30 times 10 to the 6 psi or 207 gigapascal. Okay? Kung hindi nyo po makita yung value, ari po yung gagamitin natin. Okay? This is general po for all types of steel. So whether it's a carbon steel, nickel steel, or chromium steel, or any other type po, ari po ay general value. Okay? Kumbaga, yun po kasi yung composition ng steel natin, it affects the value ng E, modulus of elasticity. So, kung wala po in particular dun sa binigay sa ating material, pwedeng ari na po yung ating gamitin. Okay? We can assume to use this value. Okay? And this is also equivalent to 30 times 10 to the third KSI. Okay? So, uunahin muna po yung dalawang procedure na sinabi ko. Pag wala po talaga, ay di ari po yung ating gagamitin. Okay? That would be for our value nung E. Okay? So, yan po yung sa atin na axial deformation. So, as applied to round specimen, again, ano nga po yung equation? Magiging 4FL over pi d squared times E. Okay? And just like po doon sa atin na strength failure, dito po, meron po din tayong i-equate. Okay? So, for a good design, ano naman po ang ine-equate natin dito? Kung doon po, we equate the design stress to the induced stress of the material, here naman po, we equate the allowable limit of deformation to the actual deformation. Okay? So, ang tawag po dito, okay, ang tawag po dyan is allowable limit of deformation. Okay? It's the allowable limit of deformation. Ibig sabihin po niyan, halimbawa po, nakalagay po dun sa statement natin is, the material is not to elongate more than 1 mm. So, ibig sabihin, hindi siya pwedeng mag-elongate more than that value. So, ang tawag po doon is allowable limit of deformation. Kumaga, pwedeng yung deformation niya hanggang doon lang sa ganun. Hindi na pwedeng lumampas pa. Okay? So, ang tawag doon, allowable limit of deformation, and then you equate that to the actual deformation. So, ito po yung 4FL over pi d squared times E. Okay? So, ito po yun ay kung, again, siya po ay circular cross-section. Kaya po ito. Pero kung hindi po siya circular, ari pong parte na rin, if this will be FL over AE. So, kung ano man pong area, yun po yung ipapalit natin doon. Okay? Now, so, base naman po dito, so yung allowable limit of deformation, this will be given. Okay? Same thing with the tensile load, force, yung length po natin, the original length, modulus of elasticity is taken from the design table. Okay? So, using this equation naman po, okay, on equating the allowable limit to the actual deformation, meron po ulit tayong makukuhang sagot. Okay? We will yield here po another dimension. Okay? So, may isa pa pong dimension tayo makukuha. Kumbaga po, ilan yung naging sagot natin? Dalawa po yung naging sagot natin, labis-labis. Isa galing sa strength, ang isa galing doon sa deformation. Okay? So, ito po yung isa, ito yung pangalawa. Okay? So, yung pong dalawa na yun, hindi po yan parehas tama. Okay? Para po sabihin natin na tama, okay, pipiliin po natin sa dalawa kung alin yung tama. At alin po yung tama. Yun po na makakasatisfy ng parehas na criteria. Criteria ng strength at criteria ng deformation. Okay? At alin po yung makakasatisfy na yon? The one with the larger diameter or the larger dimension. Okay? So, pagkukumparahin mo po yung dalawa, and then you'll have your conclusion. Therefore, it should be the larger value. Okay? To satisfy both failure profiles. Okay? Yan. So, ang pipiliin mo po sa dalawa kung alin po yung mas malaking dimension. Okay? And it should be expressed in the commercially available size. Okay? So, dalawa po yung sagot natin. Isa galing sa strength, isa po galing sa deformation. Okay? Now, there are cases po naman na wala po tayong deformation failure. Okay? So, malimit po pala na wala yung deformation failure. Okay? Ma-identify mo po kung meron kang deformation failure only when if you are given this. Okay? Pag binigyan lang po sa problem yung allowable limit of deformation, yun lang po yung indicator natin na meron po tayong solution dito sa deformation failure na isasama. Okay? Pero kung wala po itong given na to, so wala po tayong masosolve dito na dimension. Nakuha po. So, ang magiging sagot lang po natin ay base sa strength failure lang. Okay? So, galing lang po sa strength failure. At kung ano po yung nakuha natin sa strength failure, yun na po yung final answer po natin. Okay? Yun po kasi ay wala tayong deformation failure. Pero kung meron po, ang gagawin po natin is we need to compare. And you'll have to put up your conclusion on which diameter or which dimension is to be used. Okay? Katulad niya, ano dapat ilalagay? You make use of the larger value. Okay? To satisfy both failure profiles. Okay? So, yun po yung gagawin natin dito. Okay? Ano yung dimension of the machine member, okay, with an applied load na tension. Okay? So, yun po yung dalawa. May question po sila. Hello? Malinaw po ba?
Wala pa naman po, ma'am.
Okay, good. So, let us have sample problems po. Okay, unahin po natin aling sample number 2. Yan. Sample number 2, you have there a link subjected to a tensile load of 10,000 pounds. It is made up of AISIC 1020 steel normalized. If load is repeated but not reversed, and H is equal to 2B, determine the dimensions of the sections with the design based on letter A, you have there the ultimate strength, and B, you have a yield strength. So this is our link, okay? So here is the tensile load that you apply to the member, okay? So each of this tensile load that weighs 10,000 pounds, okay? So kada isa dyan, that's 10,000 pounds. And then this link is made up of C1020 steel normalized. And its cross-sectional area, okay, is rectangular in form. Okay, so ito po yung kanyang cross-sectional area, rectangular, having dimensions H and B, height, at saka po yung B for the base. Okay, so yun po yung hahanapin natin dito. Ano ba yung tamang height? Ano ba yung tamang width na gagamitin natin for the link? Okay, and then you have here A and B. Okay, A and B. This A and B, these are your basis of design. Okay, kumbaga, dalawa yung basis ng design natin. So, what should be the dimension kung i-design mo siya based on the ultimate? At ano po yung dimensions kung i-design mo naman po siya based on the yield? Okay, so yan po yung basis ng design. Okay? Kung hindi po nabanggit dito ang basis ng design, ano po kaya yung tamang basis ng design na gagamitin natin? Ultimate o yield po ba? Halimbawa, wala po nakalagay na based on A and B. Basta lang nakalagay determine the dimensions of the section. Nakalagay hanggang doon lang. So ano ang magiging basis ng design natin? Yes, Emmanuel.
Yield
Yan
strength.
po ay yield. Okay, tama. So, tama po siya. Yield po ang ating pagbabasihan kasi po ito ay ductile material. Yun po ay kung wala po aring statement na are with the design based on ultimate and yield. So, kung hanggang doon lang po, tumuldok na doon, ibig sabihin, ang basis natin ng design would be yield. Okay, given that the material is ductile. Okay? Now, so, ang isa-solve ko lang muna po ay A. Okay? Tapos, kayo po yung magsosolve ng B. So, ang A po is based on ultimate strength. Yan. So, based on the ultimate strength. Okay? Now, so we follow po yung steps involved doon sa essence of designing. Okay? So, we start first with the given values. Yan. So, ano po yung given? Una, we have the tensile load. So, the tensile load FT is equal to 10,000 pounds. So, this is equivalent to 10 kips. Okay? Divided by 1,000. Okay? O, ano pa po yung iba na given? Wala na kundi the ratio of H and B. H is equal to 2B. Okay? So, you have the relationship nung dalawa po natin na cross-sectional dimension. Okay? And then, kasunod po nung given, i-follow na po natin yung procedures. Okay? So, ano yung una? Know the property of the material. So, ibig sabihin po niyan, we are looking for the material specification. Okay, ano po yung material specification po natin? Okay, as to code, yun po ang uunahin. So, AISI C1020 normalized. Okay, so yan po yung code. Ano po ang kasunod? As to strength. So, you need to look for sigma U and sigma Y values. Okay, so pakihanap nga po doon sa design tables po natin. What would be the value of sigma U for 1020 normalized? Same thing with sigma Y. Yes, Justin?
64 kips and 54 kips po.
Oh, mali po yung kips. Ano po dapat are? 64 K
KSI po.
KSI. Okay, the other one nga. Ano nga ulit are, Justin?
54 KSI po.
64, the other one is
54 po.
54.
Opo.
The others, kindly check.
50 po.
50 po.
50. Okay, ari po yun. Tingnan po natin sa 87. Then, ano nga ba yun? We have 10, 20 normalized. Okay? So, we have 10, 20 normalized. So, ito po yun. So, the value would be sigma U is 64 and your sigma Y is 50. Sige pala to. Wait lang ha. Ano? Okay, to continue po, okay, so we have po 64 at saka po 50. Okay, 64 and 50. Naririnig po ba ako?
Yes po, ma'am.
Yes.
Okay, so continue ko lang ha. So 64 KSI, the other one po is 50 KSI. Huwag po tayo malito dun po sa unit natin. Okay? Pag stress po, it would be KSI, PSI para po sa pressure. Pero po pag mga forces, yun po yung pounds, yun po yung kips. Okay? So yun po yung ginagamit natin normally. And then later po siguro, maglalagay din tayo dito ng yung sa SI para alam nyo din po kung paano gamitin. Okay? So mostly po kasi English unit po yung mga samples po natin, okay, at yung dinidiscuss natin, even those sa table. So paano po kung bibigyan tayo nung ano naman po, SI unit. Okay, so ari mo na po. So sigma U, sigma Y, 64 and 50, again, kindly indicate po the reference table. Okay, so this would be table 87, page 17. Okay? So, yan po yung ating material specification. Okay? Okay? Now, we go now to the next step po. That would be the factor of safety. Apply a suitable factor of safety. Okay? And then you have to include here yun pong tatlong conditions. Okay? So, ano yung tatlong conditions? Una, it would be the kind of load. Okay? So, you go back to doon sa problem and then see ano yung type ng load. Okay? Nakalagay po doon. Load is repeated but not reversed. Okay? So, yun po yung i-indicate natin dito. Repeated but not reversed. Yan. O, ano po yung pangalawa? After the kind of load, you have there the type of material. This is 1020. So, ano pong type ng material ito? Miss Janela. Miss Janela? Miss Janela? Hello?
Hello po, ma'am.
Anong sagot, Ineng?
Hello po, rinig po ba ako?
Oo, naririnig ko din yung sarili ko. Hello? Nawala na si Miss Janela.
Hello po, ma'am.
Yes, Neng.
Ductile po, material.
So, this is a ductile material. Okay? So, for a ductile material, okay, ano mo nga yung recording mo, Miss Janela. Okay? So, this is the type, kind of load, the type of material, and then the other one would be the basis of design. Okay? So, what would be the basis of design? As indicated po or as required po ng problem for letter A, it should be based on ultimate. Okay? So, based on the ultimate string. So, yun po yung tatlong conditions. Now, using these three conditions po, tingnan po natin yung table 1.1. Okay? O, hanapin nyo po yung kind of load. Repeated but not reverse, ductile material, and based on ultimate. So, from these three conditions po, ano po yung factor of safety? So, doon po sa repeated but not reverse, wala pong eksaktong ganyan na nakalagay doon sa atin na table 1.1. Okay? So, titignan mo lang po alin doon yung katulad. Okay? Nung statement po na yon on the kind of load. So, alin po ang kaparehas po niyan?
Repeated one direction po.
Okay, tama. Repeated one direction. Okay, so yun po, doon po tayo ngayon titingin. Repeated one direction, ductile, and then based on ultimate. So what is the value of the factor of safety? Tingnan nga po, ano po ang value?
6 po.
Okay, tama. It is equal to 6. Okay, factor of safety is equal to 6 taken from table 1.1 page 2. Okay? So, yan po yung factor of safety. Sunod po sa factor of safety is to determine the design stress. So, design stress po ang kasunod. Okay, so for the design stress, ang gagamitin po natin ay sigma D. Okay, bakit nga po sigma D? Dahil po tension. Okay, kaya sigma po ang gagamitin po natin. And design stress would be equal to sigma U over factor of safety. Ari lang po yung gagamitin natin. Sigma U over factor of safety since this is based on ultimate as required in letter A. Okay, yan po yung requirement to design based on the ultimate. Kaya ari po yung equation. Sigma U over Fs. And then we have the value already of your sigma U taken from table 87. So, i-substitute lang po natin. 64 KSI divided by the factor of safety taken from table 1.1 that is equal to 6. Okay? So, 64 over 6 yields 10.667 KSI. Okay? So, sa inyo pong calculator, paki-recompute nyo nga po kung tama. 64 over 6. Okay, so tama
Tama po.
po. Ang makikita nyo nga lang po diyan, repeating po yung ating value, 10.66666 hanggang doon, okay? Hanggang sa pinakadulo, okay? So, dito lang po, ginawa po natin, okay? Truncate po natin to 3 decimal places, okay? Para po maliit lang yung isusulat natin dito. But then, if you will be using this value po, okay, on other formula, okay, isa-substitute po natin, kindly use po the real value. So, sa calculator po, dire-diretso yun. Okay, wag nyo na po i-truncate na ganito. Okay, otherwise po, yung final answer po natin, medyo malalayo. Okay, pag lagi po tayo na round off lang yung value. Okay, so hindi po natin siya i-round off. You simply round off the final answers po to 3 decimal places. Okay, so wala na po magtatanong yan kapag exam ha. Baka po mamaya tanong na naman sa proctor o tanong sa akin, ilan ka pong decimal places? Masasapok ko po ang magtatanong. Ha? Walang magtatanong. Sasapukin ko lamang. Okay? O, yan po ay nasabi na during our lecture. Ayan, okay, pag tayo po ay nagsosolve, yun din po ang ating ginagawa. Kaya po yun ay hindi na po katanong-tanong. Okay? Oh, so yun na po ang ating gagawin. Okay, whether it's yung pong sa seat work natin, sa design work, sa exam, lahat po ay ganun ang gagamitin po natin. And aside from that, yun naman po kapag dimensions naman po yung kinukuha natin, ano po yung tama? Lagi din naman po natin i-convert siya to the standard size. Okay? So, ano po natin siya to the standard size. Okay? Kaya, yun po yung ating gagawin. Okay? Now, after the design stress po, ano po yung isusunod natin? Yung pang-apat na po ito. Yung for a good design. Yan, nakakabini na po yung for a good design. Okay? You equate the design stress to the induced stress of the material, which is the tensile stress. Okay? So, for the tensile stress, that would be the tensile force over the area. Okay? Ano lang po yung area ngayon natin? Okay? So, given po natin, it is rectangular. So, equation po would be base times the height. Okay? So, FT, and then you have there base times the height for the area. Okay? So, yun po yung nababago kasi iba-iba yung cross-section. So, titingnan nyo po. Hindi laging katulad, ay, ang sample ni Ma'am Dong kanina is circular. Akala yun na yun ang area, ha? So, pinapalitan po yung area. Titingnan mo doon sa illustration po kung ano ba yung given doon sa problem. Okay? And then, here, you have yung relation between H at saka po yung B. Okay? You have here H is equal to 2B. So, in place of H, papalitan po natin siya ng 2B. So, this is B and this is equal to 2B. Okay? So, leaving FT over 2B squared for your design stress. Okay? So, yan po ngayon yung magiging equation natin. And from this, ilalagay na po natin or isa-substitute na po natin yung mga given values. So for the design stress, we have initially solved po the design stress based on the ultimate. Again, this is design stress based on the ultimate strength. Okay? 10.667 KSI. So 10.667 KSI equal to your FT is 10 kips divided by 2B squared. Then you solve for B. So B squared would be 10 kips divided by 10.667 kips per square inch. And then you have there 2. So you can cancel out po yung kips. Yung inch squared naman po pupunta dun sa numerator. And this is B squared. So if you take the square root, then you'll obtain your B value in inches. Okay? So ano pong sagot? Paki-compute po. Yes po. Ano bunso? Ano yung value? Hindi sa whiteboard. Din lang, ano lang, sabihin niya lang sa akin or i-type niyo din sa chat box natin. Point. Okay, so that would be 0.6846, okay, or 0.685 inches. Yan, tama po yung sagot niyo, okay? So, ari po yung nakuha nating value ng B, okay? Ang gagawin po natin, ito po yung computed value, okay? So, sabi nga po kanina, for this to be given credit, dapat po i-convert po natin to the commercially available size. So, ano po yung commercially available size for this 0.685 inches? Okay? Likewise, hindi din po dyan natatapos lang yung hinahanap natin because you are to look for the required dimensions. And for the dimensions po, B and H po yan. So, you have to look also for the value of H. So, ano po yung magiging value ng H? You need to see again yung pong kanyang relationship. H is equal to 2B. So, once po na yung B natin, okay, na-convert mo na po to the commercially available size, yun po yung ating i-substitute dito sa B. Okay? Para po yung ating H would be commercially available na din po yung size niya. Okay? Minsan po kasi, pwede din naman po, isang paraan is 2 times this computed value na 0.685. Tapos po, tsaka mo siya i-convert to commercially available. Lamang po, pagka ganun po, minsan kasi, yung nagiging value nung kasunod na dimension, okay, hindi na maintain ito pong kanyang relationship. Kasi kumbaga pumapatak siya doon sa mas maliit na value, okay, or sa mas malaking na commercially available size. Kaya hindi na maintain yung halimbawa relationship na equal siya sa 2B. Okay? Kaya para po ma-avoid yon, ang gagawin na lang po natin is yun po answer, okay, natin change that to commercially available, and then yun na po yung commercially available size, yun po yung isa-substitute natin para doon sa pangalawang parameter. Okay? Nakuha po ba? Hello?
Yes po.
Yes po,
Okay.
ma'am.
So, I'll change po muna yung yung presentation, and then I'll teach you how to obtain po yung commercially available size. Okay? So, paano po ba yun kino-convert to the commercially available size? Na-share ko po yung dito. Nasaan na yan? Jamboard.
Yes po,
Nakita
ma'am.
niyo na? Wait lang po. Yan, yung Jamboard yung atin na ipipresent. Wait po. Okay, so dinin muna po tayo sa Jamboard. Okay, so ito po doon sa Jamboard, ito po yung gagamitin natin for converting po doon sa commercially available size. So these are the commercially available sizes, or we call it po simply as preferred sizes. Okay, so ari po yung mga preferred sizes po natin. Okay, so for the preferred sizes, we have first 1/64 between 1 over 64 to 1 over 32. Okay? And then we have 1 over 32 that is between 1 over 32 up to 3 over 16. And then 1 over 16 between 3 over 16 up to 7 eighths. Okay, 7 eighths. And then we have 1/8 between 7 eighths up to 3. And then we have 1/4 between 3 to 6. And then 1/2 above 6. Okay? So all values po na ito is in inches. Okay? So in inches po lahat ito. So ano po ibig sabihin na ring preferred size? So ito po nanditong numbers. Okay? Between, tapos ito po nakalagay na mga numbers. Ito po mga nakalagay na numbers na yan po ay range. Okay? So yung pong ating answer, dito po natin titingnan saan po bang range siya kasama. Okay, so din muna po tayo unang titingin. Saang range siya kasama. Okay? Kasunod po niyan, pag alam mo na po yung range, you list down po yung available sizes. Okay? And ang available sizes po, meron po siyang increment ng ganitong fraction. O, halimbawa po, ari muna po yung sample natin. Halimbawa po, ang nasolve po natin, diameter is equal to 3.367 inches. Yan po yung nasolve natin na diameter. 3.367 inches. So, what would be the standard size for this diameter? Okay? So, ito po yung titingnan natin una. Okay? Saan po siyang range kasama? Okay? So, nandito po siya sa range na 3 to 6. Okay? So, nandyan po siya. So, ang gagamitin mo po is 1/4 interval between 3 to 6. So, you list down po the available sizes. Okay? Ano yung available sizes sa grupo pong are nung 1/4 between 3 to 6. So, you will start po with size na 3. So, all these are all in inches po ha. Okay, all in inches. So, you start with 3 inches. Kasunod po niyan, interval ng 1/4. So, 3, 3 and 1/4, 3 and 1/2, 3 and 3/4. Kasunod po ay 4, 4 and 1/4, 4 and 1/2, and 4 and 3/4. Ano po kasunod ng 4 and 3/4? 5. And then 5 and 1/4, 5 and 1/2, 5 and 3/4, and then last po would be 6. Okay? Kasi ang range po niya is from 3 to 6 only. Okay? So ito po yung mga available sizes po natin. Yan po yung mga standard sizes. So, ito po ang ating i-convert sa kung alin po dito yung gagamitin po natin. Okay? So, again, yung po na-compute natin value na yan po ay minimum allowed value. Okay? Minimum allowable value, meaning yan na po yung pinaka mababa. Okay? Pag liit po dyan, ibig sabihin po niyan, unsafe na. Okay? Pero pag laki po dyan, mas safe po. Okay? Ari po minimum. Okay? So, what would be the equivalent po nito? Saan po siya pinakamalapit? It would be 3 and 1/4. Okay? At saka po 3 and 1/2. This is 3.5. Ari po naman ay 3.25. So, alin po yung gagamitin sa dalawa? It would be the next higher. Okay? Yung next higher po. So, that would be 3 and 1/2 of an inch. Okay? So, ito po yung standard size po niya na gagamitin. Okay? Sa iba po, ang minsan, ginagamit nila yun. Halimbawa, nakita po nila dito is 3.29. Ang iba po, ari yung ginagamit, 3 and 1/4. Okay? Pero kung tutuusin nyo po doon, okay, siya po ay mas mababa doon sa 3.29 kasi 3.25 lang siya. Pero bakit po yun minsan yung pinipili ng ibang designer? It is because po, di po ba pag tayo nag-come up with this dimension, meron na tayong factor of safety na ginamit. Okay? Pero ganun pa man, okay, parang ang nangyayari doon, pag ginamit mo po iyon, is gagamitin mo na yung factor na yung kumaga yung palabis natin na inilagay, yung allowances, yung tolerances doon sa maximum capacity. Okay? So, hindi po dapat ganoon. Although, safe pa rin naman siya, pero hindi po natin yun ma-ensure. Okay? Kasi nga, nung kinuha po natin yung value, that is the minimum allowable value. So, para po sigurado, ang kailangan ang kuhanin natin would be the next higher. Kaya, ang pinipili po natin would be 3 and 1/2 in this case. Okay? Nasundan po ba yun? Nakuha po? Hello?
Yes po.
Yan. O, balikan natin yung sagot natin kanina. Okay? Ano po yung nasagot natin kanina? B is equal to 0. Tama nga, 658 nga. O 685. Ano nga? Uy, anong sagot natin kanina?
5 po, ma'am.
685. Yan. B is equal to 0.685 inches. Okay? So, hanapin mo ngayon ano yung kanyang standard size. So, titingnan mo dito saan muna siyang range kasama. Okay? I suggest para madali po ninyong makita kung saan range yan, ang gawin nyo po, kada fraction po dito, okay, i-convert nyo po into decimal. Yung decimal equivalent po niya. Halimbawa, 1 divide 64. So, anong value nito? 1/32. So, mas madali mo pong ma-identify kung saang grupo po siya kasama. Okay? Yan. So, saan po kaya itong 0.685?
3/16, 7.8 po.
3/16, 7/8 po.
Tama. Nandun po siya sa 3/16 to 7/8. Okay? With an interval of 1/16. Okay? So, ibig sabihin, ang ilalagay mo dito yung over 16. So, ano yung mga available sizes sa kanya? Saan magsisimula po? Sa 3/16. So, 3/16, tapos interval nito. So, ano ang available? 3/16, 4/16, 5/16, 6/16, okay? Until 7H, which is equivalent to 14/16. Okay? So, magsisimula po sa 3/16 hanggang 14/16. Okay? Yun po yung available sizes dito sa group na to. Okay? At saan po pinakamalapit yung 0.685? This would be equivalent to your 11/16.
11/16 po, ma'am.
Okay, correct. So, 11/16 of an inch. Yun po yung value ng atin na B. And for H naman po, that would be 2 times 11/16 of an inch kasi 2B po yun. Okay? So, we yield here 22/16 of an inch or lagi po natin i-convert siya into a mixed fraction. Hindi po aring improper. Okay? So, this is equivalent to 1 and 3/8. Okay? Inch. Okay? 1 and 3/8. This is already po in the lowest term. Kasi ang makukuha natin dyan is 6/16. Okay? So, 6/16 is equivalent to 3/8. So, siguro naman po kayo lahat ay maalam mag-convert into the lowest term. Okay? So, ang ating pong standard sizes, okay, yan po lagi ay naka-fraction. Okay? Fraction po yung ating na standard sizes. And then, yan po yung ating values. Okay? For B at saka po doon sa H. May tanong po sila. Hello?
Wala pa naman po.
Wala. Okay. So, balik muna ako dun sa module natin. Okay, so ito po, okay, wait lang Justin, tuloy ko lang to, mawawala, wait lang. So, B is 0.685, again, this is your 11/16 inch, okay? Tapos, H is equal to 2B, so this is 2 times 11/16 of an inch, and sabi nga natin, this is equivalent to 1 and 3/8. Okay? Tapos, you must have your conclusion. Okay? So, itong answer natin, itong B and H na ito, galing yan saan? Considering the induced stress. So, yan po ay galing doon sa strength failure. Okay? Designing against the strength failure. Okay? Nakuha po. Pag ito pong problem na ito, wala po siyang deformation failure. Okay? So, paano po nasabi natin na walang deformation failure? Because on the given, wala pong nabanggit as to the allowable limit of deformation. So, ibig sabihin po natin dyan, ang ating magiging solution ay base lang sa strength failure. So, ari pong lahat ng ari po ay galing lang sa strength failure. Okay? So, kung wala po yung deformation failure, ari lang po yung sagot natin. Okay? At kung yun lang po yung sagot, then that would be our final answer already. Therefore, use B equal to 11 over 16 inch and H equal to 1 and 3/8 inches. Okay? So, ari po yung atin na final answer for letter A. Nakuha po ba? Naintindihan po ba? Hello?
Yes po, ma'am.
Oh, kung,
Yes po, ma'am.
kung may nabanggit po din sa problem, halimbawa po, may nabanggit po din sa problem na allowable limit of deformation, hindi pa po ari yung final answer natin. Okay? Maggagawa ka po ng isang solution, okay, that would have the deformation failure. So, magkakaroon ka pa ng isa uling sagot. Tsaka ka po pipili. Okay? Tsaka ka magkakaroon ng conclusion. So, mamaya po dadagdagan natin itong problem po na iyon, isasama po natin yung deformation failure. Okay? Now, paki ano naman po, okay? Kayo naman po yung gumawa ng letter B. Okay? Yung B po is based on the yield strength. Okay? So, gawa po natin yung based on the yield strength. So, alin po yung papalitan natin dito sa initial solution natin sa A? So, given at material specs po, the same, dito po sa factor of safety. So, ari po, magiging repeated, but not reversed, ductile, and based on yield. So, iba na po ang value ng factor of safety. Ganon din naman po ang design stress. Ang design stress po ngayon, mag-iiba na din yung equation. Sigma D should be sigma Y over Fs. Okay? Bakit? Based on the yield na po. Okay? And then, the same tensile stress, na iba nga lang po yung design stress, kaya you would yield a different answer. Okay? So, kindly work on letter B po, and then you post your answers po doon sa Jamboard po. So, papalitan ko lang po for you to be able to put on your answers po doon sa Jamboard po natin. Okay? So, pakigawa nyo muna po yung letter B. Do not use lang po pala yung slides 19 and 20. Okay? Kasi gagamitin ko po yan. Okay? So, doon po kayo mag-post sa 1 hanggang 18. Naintindihan po ang gagawin?
Yes po, ma'am.
Hello? Okay, good. Okay, access is updated. So you may post na po your answers here po. Again, from slide 2 to 18 lang po. Okay, I'll be using 19 and 20. So ang gagawin po natin yung letter B, base design on the yield strength. You can use po pala until 19 kasi hanggang 21 po. So I'll use 20 and 21.
pagka-graduate.
O, ano po answers natin? Ano po nakuha niyong sagot?
Dahil
Hello? Yan, tama po ate. 9/16 and 1 and 1/8. O yung iba ho, ganun din?
Yes po, ma'am.
Okay, so paki-post lang po yung answers po ninyo. Okay, 9/16 for B and H is 1 and 1/8. Okay, so yun po yung answers natin. Okay, so idugtog lang po natin ito to problem 2. Okay, magta-time na po kaya anan ko lang muna po ito. Okay, so ito pong letter C, idinagdag ko po ito for the deformation failure. Okay, so paano po kung may deformation po na binigay? Okay, so if the length is to elongate not more than 0.15 inch, how will the dimensions in A and B change? Okay, so consider a 1 foot length link. Okay? So, ito po yung length niya at ito pong value na binigay na ito po yung tinatawag natin as the allowable limit of deformation. Kumbaga po, yung link, hindi siya pwedeng, okay? Hindi po siya pwedeng mag-exceed up to 0.15 inch, okay? So, yan po yung gagawin po, okay? So, ito po yung indicator, okay? Pag binigay po yung allowable limit of deformation, yan po yung indicator na meron po siyang deformation failure, okay? So, let us have now po the deformation failure. Ano yung magiging dimension po natin kung i-consider po natin ito, okay? Yan. So, for the deformation failure, okay, we equate po our allowable limit of deformation to the actual deformation, okay? And the actual deformation, this is simply FL over area times E, okay? And from our previous example po, dun sa A and B, yung A po is BH, and then incorporating B is equal to, H is equal to 2B, we come up with 2B squared. And then you have there the value of E. Tapos, i-equate po natin sa allowable limit, okay, nung deformation. So, yun po ngayon, hanapin po natin yung value ng E, okay? So, saan po natin makukuha again yung value ng E? Doon po sa mga design tables po natin, okay? Given yun pong material, okay? So, using po yung ating table 87 for C1020 normalized, okay, pakihanap na po ulit natin yung value po ng E. Hello, ano po yung value ng E? Pakitingin po. So, saan po natin titingnan? The same table 87. Okay, ano po ang value ng E?
30 times 10 raised to 3 KSI po, ma'am.
Okay, correct. So, 30 times 10 to the 6 PSI. Okay, this is taken from table 87, page 14. Ano po yung katulad nung sample kanina. Okay, nakita po natin yung value ng E doon po sa may heading po nung table. Okay, so yun po yung value ng E. Now, i-substitute na po natin ngayon yung mga values po. Okay, so the allowable limit, so ilagay ko lang po muna ulit yung equation. Allowable limit is equal to FT L sub O over 2B squared, then the value of E. Allowable limit, iyon po yung 0.15 inches. Equal to yung FT po, that is 10 kips. Original length, you have here, consider 1 foot length link, okay? Yung 1 foot po, you convert that to inches. So that is 12 inches over 2B squared. And then E is 30 times 10 to the third, okay? So ginawa po natin KSI, okay? So this is kips per square inch. Kaya po naging 30 times 10 to the third instead of 30 times 10 to the 6. Okay? So, kinonvert na po natin into KSI. Okay? So, you can cancel out here po yung kips, yung inches. So, ang matitira po would be inches squared. Okay? And this is B squared. So, if you take the square root po, you will obtain the value of B. Okay? So, what is the value of B? Paki-compute nga po. Yes po.
0.115 inches po, ma'am.
Okay, correct. 0.115. Okay?
Gora.
Yan, 0.115. And if you take po yung kanyang standard size, yung 0.115, ano po yung standard size nito?
Oo. Saulado na.
Okay, ano po yung 115? 0.115, standard size. Hello?
1/4 po ba, ma'am?
That is 1.
1/4 po.
This is equivalent to 1/8. Okay, correct. So this is 1/8 of an inch. Okay? And then for the value of h, this is equal to 2b. So this is 2. B is 1/8 of an inch. So we arrive at 2/8 inches. So on the lowest term, this is equivalent to 1/4 of an inch. So B is 1/8 and your H value is 1/4 inches. Okay? Yan po ay kapag ang kinonsider natin ay deformation failure. Pero we go back to our dun sa problem. Ano po ba yung requirement? Sabi dito, if the link is to elongate not more than 0.15 of an inch, how will the dimensions in A and B change? Okay? So, babalikan po natin yung A at saka yung B po natin. Okay? So, for letter A, you are asked to design based on the ultimate strength. Okay? Based on sigma U. So, base sa strength failure, ano po yung nakuha natin kanina? Okay? We arrive at B equal to 11/16. Kindly check nga po ha, pagkakatanda ko lang. 11/16 of an inch and h is equal to 1 and 3/8 of an inch. Okay? Tama nga, tama nga. Okay, yan po yung sagot natin base sa strength. Tapos, ngayon po, base sa deformation failure, ano yung nakuha nating sagot? Okay? So, tingnan po natin yung nakuha nating sagot. D is 1/8 and yung H po is equal to 1/4 of an inch. So, ibig sabihin po, kung may deformation failure po siya at may strength failure po siya, titingnan po natin, i-compare po natin yung dalawa. Whichever is higher, okay, dun po sa dalawa, yun po yung pipiliin natin. Ibig sabihin, that would satisfy po both yung conditions po na yun, okay? Both yung failure profiles po na yun, okay? So, therefore, ano po yung gagamitin natin ngayon? Alin po yung mas malaki dun sa dalawa comparing the strength and the deformation failure. Therefore, you use, alin po ang mas malaki? Yung galing po sa strength failure. Okay, correct. Use B equal to 11/16 inches and H equal to 1 and 3/8 inches. Okay? So, ano po yung sagot po natin? Okay? So, kino-compare mo po yung dalawa mo pong answer. Okay? Nagkataon lang po kanina dun sa letter A, wala pa po yung deformation failure. Pero kung meron po, dapat po i-compare mo po siya at yung po mas malaki, yun po yung gagamitin nating final answer. Okay? Yun na po yung tamang sagot. Okay? Letter B, based on the yield. Okay? So, sa strength naman po, ano nga po yung nakuha nating sagot kanina? B is 9/16. And ano po yung H?
1/8.
1/8.
Okay, 1 and 1/8 inches. At sa deformation failure naman po, tingnan po ulit natin. You look at the deformation failure po, okay? So, deformation po, based on the yield, ito din po yung sagot niya, okay? Kasi ito naman pong deformation failure is not, okay, dependent on the basis of design. Whether it's based on ultimate or based on yield, wala pong mababago dito, okay? Kasi base po yan doon sa deformation, okay? So, ibig sabihin po, yung values po din the same lang po nung nasa kanina. B is 1/8 and H is 1/4. Okay? So, therefore, what would be our answer? Okay? Again, we make use of the bigger values. So, alin po yung pipiliin natin? B is 9/16 and H equal to 1 and 1/8 of an inch. So, ari po yung final na gagamitin. Ito po yung dalawa. Okay? So, the dimensions change. Okay? kahit po yung may deformation, okay, yan pa rin po yung pinili natin. Galing doon sa strength failure kasi siya po yung nag-yield ng mas malaking dimensions. Okay? Nakuha po ba yung sagot? Hello?
Yes po, ma'am.
Okay, good. Okay, so I hope po yung iba nalagay din dito yung ano nila, or kung hindi man po nalagay dito ay you've got po yung tamang sagot po natin. Okay, so ganun po natin din design ang members under pure tension. Okay, based on the strength failure and based on the deformation failure. Okay, sige po, I'll stop na po my presentation. And then kindly open po your camera for our attendance. All mark ang ating attendance.
Yes po, ma'am. Noted po.
Okay, take charge po for the screenshots. Okay na?
Wait lang po, hintayin ko lang po yung internet. Medyo mabagal lang po sa akin.
O yung iba, bakit hindi nag-open ng camera? Nakakamang.
Hindi po. So po, ma'am. 1, 2,
Sige po.
3.
Okay na?
Yes po, ma'am.
Okay. O, sige po. Bye po.
Thank you po, ma'am. Bye.
Sige po,
Thank you
ma'am.
po, ma'am.